Today's video, we're going to take a look at problem solving with linear equations. So I have this box here with just general terms that you might look for in sentences that would translate to actual operations. So I'm not going to read through all these, but you could use this as a little bit of a guide just when you're reading through problems, what operation is actually asking for. Like increased by, that means addition. We're increasing something, or subtracted from, like that's just subtraction, or decreased by, that's subtraction, and so on. So let's go ahead and take a look at some problems. We have finding an unknown number. Number one, 9 subtracted from 8 times a number is 39. Find the number. So we have the number 9 being subtracted from 8 times a number. So we have to be careful on how we arrange this. You might think it's either 9 minus 8x or 8x minus 9. Like those are the two things that you might think. When it's subtraction, it is very important that we get the order correctly. We can't wait if it's addition, like 9 added to or plus or something like that, then the operation, the order doesn't matter because it's addition. But with subtraction, it's very important that we get this correct. So it says 9 subtracted from 8 times a number. So that means I want to take 9 away from 8 times some number, and then they're saying that's equal to 39, so is 39. So then we have to actually solve the equation that we just set up. So I have 9 being subtracted from 8 times a number. If I'm taking 9 away from something, I am taking 9 away from 8 times some number, the number we don't know, so I'm just going to call that x. The word is means equal, find the number. Now this is just an equation, so we're going to add 8x equals 39 plus 9 is 48. Divide by 8, and x equals 6. So once we get down to this point where we have these equations set up, if your solving equation skills are strong, then the hard part is over. Then it's just boom, solve, done. But if your solving equation skills are a little bit weaker, then that's something that you want to go back and practice and just get better at, because then that makes problem solving that much easier. Number 2, 5 more than 4 times a number is that number increased by 35. So 5 more, what operation is more? That means addition. 5 more than 4 times a number. So that means I want to add on 5 to 4 times some number. So 4x plus 5, where it is, gives us equals. That number is the unknown number. So whatever that number is, whatever this number here that I called x, that number increased by 35. So and then after you write it down though, go back and read it. 5 more. Sorry, I thought I flipped them. But 5 more, so plus 5, then 4 times a number. So whatever 4 times a number is, we're taking 5 more, and that is equal to that number plus 35. Now the hard part is over, so now it's just the solving. So let's subtract x from both sides. I get 3x plus 5 equals 35. And then we want to subtract 5 from both sides. 3x equals 30. And we divide by 3, giving us x equal to 10. Number 3, 4 times a number minus 8 is equal to 3 times the number plus 5. Find the number. So 4 times a number minus 8 is equal to, so this is a little bit more straightforward because it's saying is equal to, that's a little bit of a clearer equal to, 3 times the number plus 5. Find the number. What it's always good to do is just go back and read it again. Read your number sentence back to the actual verbal sentence. So 4 times the number, 4x, minus 8 is equal to 3 times the number plus 5. So that directly translates from what I just read into that sentence that I just created my equation from. Now we're just solving, so this is actually a little bit of a manageable equation here. So 4x minus 3x is 1x. Let me actually, so I subtracted 3x, so 4x minus 3x is 1x, minus 8 equals 5. I was going to skip a step, but I'll just go ahead and write it out, not a big deal. And then we just have to add 8 to both sides, giving us x equals 8 plus 5 is 13. So that's the first thing we could do with linear equations, the first type of problem solving that we could take a look at. Next one, finding the length of an object. A 72-inch piece of wood is cut into 2 pieces so that the longer piece is 5 times the shorter piece. Find the length of each piece. The habit that people get into with these types of problems is they will create an equation, they'll solve for x, and then they'll call it a day. Like they won't actually answer the question. It says find the length of each piece. So we do have a little bit more than just getting x. We have to actually solve something. So we have a 72-inch piece of wood. It's cut into 2 pieces, that the longer piece is 5 times the shorter piece. It doesn't say anything about cut in half. I know a lot of people like to just read these type of problems and assume half, like they'll put a line here. But it's telling us that one piece is 5 times longer than the shorter piece. So we have a short piece and we have a long piece. Now it doesn't say anything about the short piece. So what I'm going to do then is I'm going to call the short piece x. Because then it says the long piece is 5 times the shorter piece. So if I call the short piece x, this long piece is going to be 5x. And if you're not sure on like how that translates, put numbers to it. Say that the short piece is 10 inches or 10 feet or whatever units you're using. If this short piece is 10 inches, then this would be 50 because it's 5 times the shorter. If this piece is 100 inches, this would be 500. And then you could directly see that relationship between the short piece and we are just multiplying that short piece by 5. So whatever that short piece is, you're multiplying the short piece by 5 for the longer piece. Now we just set up an equation. So if I know that the short piece plus the long piece, that is equal to 72 inches because this entire piece was cut and we cut it into 2 parts. So I'm going to say x plus 5x is equal to 72. So I just take the fact that I know short piece plus the long piece is going to make up the whole piece of 72. So x plus 5x is 6x equal to 72. We then divide by 6. Once we get that equation set up, that's the hard part, is the setup. Solving should be the easy part. And that gives us x equal to 12. Now we are not done. It says find the length of each piece. So the shorter piece we just found to be x. That was 12. The longer piece is 5 times x. So 5 times 12. So whatever our x value is, which we got to be 12, it's 5 times 12, which is 60. So the long piece is 60, short piece is 12. That's the question that you need to answer. Not just identifying x, but the actual how long is the short piece, how long is the long piece. Let's take a look at another one of these scenarios. A 35-foot steel beam is cut into 3 pieces so that the second piece is twice as long as the first piece, and the third piece is 3 feet longer than 5 times the length of the first piece. Find the length of the pieces. A lot of people will get overwhelmed with this type of problem. Like they'll read that and they'll be like, I don't even know where to start. Like there's just a lot. Draw a picture. We have a 35-foot steel beam. Okay. It's cut into 3 pieces, so just make 3 marks. Don't worry about the proportions or anything. We just have 3 pieces. 1, 2, and 3. Okay. It says that the second piece is twice as long as the first, and the third piece is 3 feet longer than 5 times the length of the first. So now notice, both the second piece and the third piece are referring back to the first piece. They're relaying that information, how long the second piece is and how long the third piece is, in regards to the first piece. So we don't know how long that first piece is. That's going to be my x. And then from there, I could create expressions related to the first piece. So the second piece is twice as long as the first. Twice as long means doubling it, so that's going to be 2x. The third piece is 3 feet longer than 5 times the first. So how do I represent that? 3 feet longer than 5 times the first. So 5 times the first means 5x, and I want it to be 3 feet longer. So what do I have to do? I have to add 3 to that piece. Find the length of the pieces. Same thing as what we looked at on that last one. We have 3 segments being totaled together to make up the whole. So I'm going to have x plus 2x plus 5x plus 3 is equal to the total length of the steel beam, which is 35. X plus 2x plus 5x, 5x plus 2x is 7x, 7x plus 1x is 8x, plus 3 is equal to 35. Subtract 3 from both sides, we get 8x equals 32. Divide by 8, x equals 4. So again, not the answer, just what x is. So we have piece 1, that was our short piece, that was just x, so that's going to be, why did I put 8? What was it? X equals 4? Yeah, it's a short piece, so that's going to be 4. And we're looking at feet here, so 4 feet. Piece number 2, that was double the short piece, or the first piece. So that's going to be 8. That one's going to be 8. 2 times 4 is 8. So 8 feet there. And then piece number 3, that was 5 times the first plus 3. So 5 times 4 plus 3. 5 times 4 is 20. 20 plus 3 is 23 feet. And there are our 3 lengths. So 23 feet, 8 feet, and 4 feet. Good problem there. That was a good one to apply a lot of skills there. Okay, a couple more problems. Finding unknown quantities involving relationships. In 2011, Ohio produced 717 million pounds more apples than Illinois. Together, the two states produced 1717 million pounds of apples. Find the number of apples in each state. So here we have a problem where we have the amount of Illinois' apples compared to Ohio's apples. It says Ohio produced was 717 more. Okay, well, I don't know how many apples Illinois produced, so I'm going to call that X. What I do know is that Ohio produced 717 million more. So if they produce 717 million more, I would just add on 717 to Illinois' amount. If I call Illinois X, I don't know how many apples they produced. So if they produced X, Ohio then produced 717 million more than that. And then it says together, they produced 1717 million. So together, if we combine them together, Illinois plus Ohio is going to give me my total of 1717. So if I take Illinois, which is X, my unknown, plus Ohio, which is Illinois, plus 717, is equal to the total of 1717. And then we just have an equation to solve from here, which is a solving equation exercise, which the setup looks complicated. Like that looked like a hard problem. But the setup here is just X plus X, which is 2X, plus 717 equals 1717. Minus 717. 2X equals 1717 minus 717 is 1000. Divide by 2, X equals 500. Find the number of apples in each state. So X is 500. What did X represent? X represented Illinois' amount. So Illinois produced 500 million. And then Ohio produced 717 million more than that. So 500 plus 717 more. And I'm not trusting my mental math right now. It is very late. 1217. It's 1217 million apples, which is actually translate to 1.2 billion apples. Okay. All right, good. Good problem there. I think I just got one more here. Yeah, one more on this video. Finding angle measures. It says two angles of a triangle have the same measure, and the third angle is 30 degrees greater than the measure of the other two. Find the measure of each angle. So we're given a triangle. Perfect triangle. And we're told that two angles of the triangle have the same measure. The third angle is 30 degrees greater than the measure of the other two. So we know we have two angles that are the same, so I could call those X. Now we're told that the third angle is 30 degrees greater than the measure of the other two. So the other two is X, so this is going to be X plus 30 then. And the fact you want to know here is that all angles in a triangle add up to 180 degrees. Any triangle is going to always add up to 180 degrees. So I have two angles that are the same, X and X. I know that because it's told us two angles, right here, two angles have the same measure. Third angle is 30 degrees greater than the measure of the other two. So if the other two are X, 30 degrees more would be X plus 30. So now that we know all angles add up to 180 in a triangle, we just say angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. And then from here, it's an equation to solve. So X plus X plus X is 3X equals 30 equals 180. Why did I just write equals 30? 3X plus 30 I'm not sure if I said equals or plus, but I actually wrote plus. All right, so we wrote equals, but it's 3x plus 30, so we have to subtract 30. 3x equals 150. Divide by 3x equals 50. So x equals 50. What does it want us to do? Find the measure of each angle. So if x is equal to 50, this angle is 50. This angle is 50. This angle is then 80. Double check your work. 50 plus 50 is 100. 100 plus 80 is 180. All angles in a triangle add up to 180. So this is the first introduction here to problem solving with solving equations.